Okay, now we're moving on to the dihybrid cross. The rules for the dihybrid cross are going to come from the monohybrid and incomplete crosses. You need to read the problems and understand if there's complete dominance or incomplete dominance for traits. However, in these crosses, as you can see from the picture, we're going to be crossing 2 traits at a time, so we'll need 16 boxes in our Punnett square. You still need to look and read for homozygous dominant, homozygous recessive, but in the 4-box Punnett squares, since we, in that case, only had to have 2 letters in each box, because we always have 2 letters for each trait, hopefully you can see that in this box we're going to have 4 letters for each trait. So we'll go ahead and talk about how to do that in 2 practice problems here. So it says dark hair is dominant over blonde hair. So dark, dominant over blonde. And widow's peak hairline is dominant over straight. So let's use an H. So a peak is dominant to straight. If 2 people who are both heterozygous for both traits had children, what are the genotypes and phenotype ratios for the possible offspring? So we're heterozygous for both traits. We're heterozygous for color, and we're heterozygous for hairline. It says both people are heterozygous for both. Now, this is going to be a little bit different when we fill in that Punnett square. I'm going to move that line over a little bit. We can't just put one letter like this on the side, because that would not result in getting 2 alleles for each trait. So instead, we have to figure out the combinations of letters from each parent. To do this, you can use foiling like in math class. So if I take this parent, I can foil the trait, do the first of each trait, the outer of each trait, the inner of each trait, and then the last of each trait, and put those down the side. You always want to use that foiling method. I'm going to go ahead and erase the foiling method over here just so I have room to do the rest of my problem. Now, since both the parents are the same, we know that it'll be the same allele combinations across the top. When you're filling in this Punnett square, I'd really recommend to keep one letter always in front, and then within that letter keep the capital letters first. So what I mean by that is I'm always going to keep my D's in front, but then if I do have a lowercase letter, I'll keep my uppercase letter first. The big thing about this problem is keeping yourself organized from the very beginning, because it is going to be a lot of letters and it's going to be a lot to count through. So you really want to take your time and make sure that you're carefully filling in that Punnett square. And it does just take some time. Here you can start to see why we've made such a big deal about using letters that are different, uppercase and lowercase, because it does all start to get difficult to hold it together in your brain. Even if on the monohybrid and dihybrid crosses you've been able so far to visualize and not have to fill in the Punnett square to find the answer, you are probably going to find yourself needing to fill in these dihybrid crosses. So now that you've done all that work, we still have to count up the genotype and phenotype ratios. And once again, I would encourage you to be as neat as possible with your work. Start in the top box, write down the genotype, and scan through and see if you have any more. I only have 1, so I'll write down 1 out of 16. Go to the next box, write down the genotype, scan through, see if you have any more. Looks like I have 2 out of 16. Go to the next one. 2 out of 16. Write down the next one. 4 out of 16. One out of 16. See how I'm just systematically working my way across the Punnett square. And the other thing you'll notice is I did not reduce any of my fractions. Leave everything with that exact same bottom number. It'll keep the work a lot easier for you in the end. Now, even with all that work, we're still not done because we do have to count up the phenotypes as well. Now, if you filled out your Punnett square and counted up all your genotypes, use your genotypes to count up your phenotypes. So what I mean by that is go through and figure out, well, my first combination, and I'm sorry, I'm going to have to erase just a little bit over here so I have room to write this for you guys. Let me erase just a little bit over here. My first combination that I have is going to be dark hair with a widow's peak. So I go down my list and I just check anybody that would have dark hair and a widow's peak. I'm just scanning and seeing any of the genotypes that have a big D and a big H. And then I count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I go to my next trait, which would be dark hair with straight hairline. And I count those. Anything that has a big D but no big H. So 3. My next combination would be blonde with a widow's peak. So little D's with a big H, 3. My last combination would be blonde with a straight hairline. I just have 1 left. Now I'm going to double check my math to make sure that adds up. 9 plus 3 plus 3 plus 1 is 16, and there's 16 boxes in my Punnett square, so I know that I've done the math correct. One thing you might notice, and you might start to see a pattern on, is anytime you do a dihybrid cross where you actually cross 2 individuals that are heterozygous for both traits, it is actually the most possible work that you can get asked to do because it will have the most possible genotype combinations, but it will always also come out, if you're just doing a regular dihybrid cross, in a 9:3 to 3:1 ratio, so it might save you some time. Now hopefully your work is a little neater than mine is here, as I'm trying to go quickly on my iPad screen. But you should be able to come up with the same answer here for listing all the genotypes and all the phenotypes. One more problem for dihybrid practice. In rabbits, the allele for short hair is dominant over long, and black fur is dominant over brown. Cross a heterozygous short hair and a homozygous dominant black fur rabbit with a female rabbit that is homozygous recessive for both traits. What are the phenotypes and genotypes of their offspring? Now these problems are starting to get very wordy, so go ahead, pause the video, decipher what that means, and see if you get the same answer as me. Did you get the same answers as I did? Did you remember to FOIL both parents so that you were going to end up with 4 letters in each box? Do you notice that I took some shortcuts in the Punnett square when I knew there was patterns instead of rewriting the same letters over and over again?